If you have not turned in your 10-4 worksheet, make sure I do get that before you leave today. In addition with the 10-5 worksheet you're going to get today. But 10-4 you got Tuesday. So if you make sure I get it in the bin before you leave me. Okay. All right. Here we go. Going into today. So we know what a geometric sequence is. Now we're going to explore it a little bit. Okay. A bungee jumper jumps from an initial height of h0 of 150 feet. The jumper's rebound height is 60% of the previous heights. What are the first 4 rebound heights? So a rebound, for my visual people, is when something like bounces, right? But it's not as tall each time. So this is showing a bungee jumper jumping off a cliff, and each time he bounces back up, he's 60% of what the previous height was. Does that visual make sense? Okay, so that's what a rebound means. Okay, so let's find our first 4 rebounds. How can I find the height of the first rebound after he jumps? Kind of. How do we find 60% of 150? She's on the right track. Yes. Yes, which is the same thing as multiplying by 0.6. So that's technically correct. That's all that in one step. So to find 60% of a value, we take that value, multiply it by 0.6. Remember our percentages, move our decimals back twice to change it into a rate of 0.6. All right, so what is 150 times 0.6? 90, thank you. So now how can I find the height of the next one? Multiply by 0.6 again. I'm going to multiply 90 times 0.6 to move forward. That's going to give me 54. How can I find height 3? Multiply what by 0.6? The 54. Good. Times 0.6. And then we're going to take 32.4 and multiply that by 0.6. So each height is getting smaller. If you think about a bungee jumper, that makes sense. Because #gravity, right? Bounces are not as tall. All right, so let's think about what I did to move forward. So my first height, I took our initial value and I multiplied it by the percentage, right? The second rebound, I multiplied my initial value by my rate twice, right? We took my initial value, the one before it, I multiplied by 0.6, and then to move forward, I multiplied it by 0.6 again. That's how we get 0.6 squared. So what did I do to get to my third height? Yes, 0.6 cubed, because I took my previous term and multiplied it by 0.6 again to give me our initial height times 0.6 cubed. Is essentially what you're doing. Each time you move forward, you multiply by another 0.6. So each time you move forward, our exponent is increasing, because that's how many bounces happen. That's how many times I've multiplied by my percentage. So how is each of these terms related to the one right before it? How is 90, 54, 32.4, 19.44? How are those related to each other?
The A is the answer
from the one before, and then how do I move forward? Right, so each term is 60% of the previous term. So multiply by 0.6 means I'm only taking 60% of my previous answer along. Okay, they're getting smaller. If I was growing, that rate would be like 1.2 something, or 1 point anything. That 1 shows 100%, and then the 0.2 I don't know, 7, shows I'm adding 25% to my original value. So if values are growing, we're going to be above 1 to show all 100% plus extra. If we're decreasing like this one, then my rate will be 0.6, 0 point something to show it's not all moving forward. All right, let's take it one step back. What if, to like create an actual formula, what if I don't know my initial height? Let's call it A. Let's not call it 150, let's call it A. And what if I don't know the rebound? I don't know it's 60%, we're just going to use R. How could I write my first rebounds? Well, I'm starting at what? I don't know that anymore. We're A, and what have we used for A now? We're not going to use A1, we're going to use A0. Okay, so A0 is coming back in. This happened with arithmetic also, because this is showing that my jumper has not jumped yet. This is where he's standing. Because my N's stand for how many rebounds occurred. He hasn't jumped yet, there are no rebounds yet. But how do I show he has a rebound? I take our initial value and I multiply it by the R. How do I get A2? I'm sorry, H2? AR squared, good. Because I took my previous guy and I multiplied it by another rebound. How do I get H3? AR cubed, good. I think you see a pattern. How do we get the fourth? AR to the fourth. So how could I find any height for any rebound? AR to the whatever, which we use N. Yes, we use N for the whatever. Yes, good. So it looks like we have developed a new explicit formula, which happened with arithmetic, right? We had an A1 and an A0 formula. We have it here also. So if we're using an A0 value, we multiply it by our rate, and our exponent is just the how many terms we're looking for. Just like arithmetic, this will be situational. Depends on what they're giving me to determine which one's appropriate. All right, so quick review. This sequence is called a, what kind of sequence is this? Not arithmetic anymore. Geometric, there you go, good. Our explicit formula, where A1 is the first term, is going to be A1 times R raised to the n minus 1. We talked about doing n minus 1 because you can't use A1 twice. You have to subtract it out of there. Remember, n's how many terms I have. If I've already used my first term, I got to take it out of that exponent. And then recursive formula, we use the previous value and then multiplied it by my ratio. This is what we did Tuesday. This is what we did Tuesday. This is a summary of Tuesday. On the back of our notes, we're going to bring in the new stuff from today. Okay? So bottom of the front is a summary of Tuesday. And then the back of our notes, we're going to add in our new equation and write the difference between the two. So, if we have a 1 being first, we're going to use what we just wrote. Now I also know that if I have a 0 representing my first term, like the situation of the bungee jumper, then we can use a 0. If they give me A1 or A0, we can use the rate to find the other piece as well. So if they give me A0, but they ask me to use the equation that uses A1, I can still figure that out. As long as I have one, I can get to the other. Is my recursive formula going to change for geometric because my first term is going to change? Do I have a second recursive formula? No, because recursive doesn't matter about the first term. It doesn't care. Recurse only reverse. They only care about what happened right before it. So now we have all of our formulas to work with. So let's work with them. Excuse me. Ready? 1 second. Our first example doesn't give me A1 or A0, does it? It gives me, what, the fourth and the seventh term? Okay, so using the fourth and seventh term, it wants me to find the common ratio, and then we're going to use that to help me find my A0 term. Okay, so first, A4 to A7, 4, 5, 6, 7, right? So I have this one and I have this one. How many times did I use my ratio to get to my seventh term? I used it 3 times. So I can say A4 times my ratio 3 times led me up to A7. This is how we're going to find my ratio. Use what they gave me, A4. To get to A7, I multiplied my ratio, whatever it is, 3 times. So I can say A4 times R cubed equals A to the 7th. That's how we got there. All right, we have A4 and A7. A4 is negative 1.56. A7 is 0.01248. So I'm putting my terms actually in my equation, so that way all I'm missing is the R. We're trying to find my ratio here. I need to separate that negative 1.56 first. How is it being attached to my R? So how am I going to move it over? We're going to divide it. We're going to divide both sides by negative 1.56. So now I'm going to have R cubed equals negative 0.008. My R is not by itself. What is still attached to it? A cubed. Yes, how do I undo a cubed? What's the inverse? A cube root. Beautiful. So we're going to cube root both sides. Do we what? No, but that's going to be an actual number. So when I cube root negative 0.008, we're going to get a value of negative 0.2. So here is my ratio. We're allowed to cube root negative numbers. We can odd root any negative number. We can't even root negative numbers. So this one's fine. Yes? I'll show you in a minute. Yep. All right, so now I have my ratio. Now I can go backwards. Now I can go back to find my term 0. Okay, I can use this. I'm going to use my A0 formula. That's what we're looking for, right? So I'm going to use the formula that has A0 in it. I know my R, it's negative 0.2. I can also plug in a term. They gave me A4, they gave me A7. I am personally going to use A4. So I know my fourth term equals my first term times my rate of negative 0.2 raised to the power of 4. All right. I also know what A4 is. It is negative 1.56. I also simplified this piece right here. When you plug this in, make sure you do parentheses, because if you don't, you're going to get a negative number. Right? Parentheses versus no parentheses. Here, your calculator actually does the whole parentheses 4 times. Okay? Down here, what it'll do is it'll separate it. It'll do -1 times 0.2 to the fourth. So it'll do -1 times whatever that is. Does that make sense? So you gotta group it together so your calculator knows to keep it all together. Otherwise, it'll do order of operations. It'll exponent and then multiply. Okay? So make sure you, whenever I type in any ratio, I always do parentheses. Raised to an exponent. All right. I'm almost there. How can I find my zero term? How am I going to get rid of 0.0016? Almost. How is it being attached right now? It's being multiplied. So how am I going to, what's the inverse of that? We're going to divide. Divide each piece by 0.0016. And we end up with -975 for my first term of this sequence. All right, so now it wants me to write both formulas. I have everything I need. I have my R and I have my A0. Okay. Do I need both of those, one of those, none of those to write the recursive formula? Adjusting my R, adjusting my common ratio for my recursive formula. Because I'm going to take my previous term and multiply it by my R. So I'm going to say A sub n minus 1 times -0.2. So I'm going to write down what we have. -9. This is what we did on the last slide. I'm just writing it down so we see it. But you have it on your paper. All right, now it wants me to write the explicit formula. Well, it made me find A0, so I'm going to find the formula using A0. So AN is going to equal my A0 times my ratio times raised to the n. So I replace my A0 with -975. I replace my rate with the -0.2. Again, notice the parentheses. Make it a habit. That way negatives won't ever trip you along the way. Questions for me so far up to this point before we get to our last example? Okay, here we go. The last example actually gives me what I want, doesn't it? It gives me the first term and it gives me a ratio. Okay, the first term, A0, oh look at that, it even told me it's A0, is -4, and my common ratio, which is R, is -3. What are the A1 and A2 terms? So how can I use what I got to find A1 and A2? Okay, multiply 4 by -3, and that gives me, go back, there we go. That gives me 12, so this was A0, it's -4. We multiplied it by -3 to move forward, and I got 12. All right, and then how can I find A2? I can take 12 and multiply it by -3 to give me, what's 12 times -3? -36. Okay, that's using the recursive formula, or you can take your first term and multiply it by your ratio twice. Come on. There we go, like that. So this is using the explicit formula. Up here, we use the recursive. Two ways to get there, we have the same answer. So however you wanted to do it. All right, let's write the recursive formula. So if you do what was in the red, what did we do each time? We multiplied by -3 to the previous term. So my recursive formula is going to be A sub n minus 1. Come on. Why aren't you going forward? There we go. Okay. All right, now it wants me to write the explicit formula, right? It doesn't tell me which one. It just says write the explicit formula. What did they give me in my information? A0 or A1? They gave me A0, but in my first question, I also found A1, right? I have both of them, so you can write either one. The choice is yours. It's whatever one you want to do. Okay. So the explicit sequence, we could either do, oh man, come on, there we go. We could use the A sub 0 formula, or come on, baby, you can do it. All right, or we can use our formula with our A1 term. Okay, so either one works. This is A0 times R to the N. This was A1 times R raised to the N minus 1. Because we had both pieces of information. Pick the one you want to use.
There should be a negative 12.
Nope, it's positive 12. Because my A0 was negative 4. So that times my ratio of negative, yeah, it makes it a positive. All right, so using whichever one you want, either A0 or A1, one of those explicit formulas, you and your table friends find the 10th term and find the 21st term. All right, ready, set, go. All right, lovelies, check your answers with mine. So the 10th term, I used the A0 formula for these. So I did negative 4 times negative 3 raised to the power of 10. Negative 3 to the power of 10 is positive 59,049. Again, parentheses matter. Multiply that by negative 4, and we get negative 263, 196 for the 10th term. Okay. Now, the 21st term. There's a reason why we did this one. Because look at that answer. That's a hot mess. Right. Some of you might have an E, right? You have like E to the 10. It means the same thing. All right, chemistry people. Remember those sig figs? Whoop whoop. Yes. So bringing this up on purpose because this happens when the number is too big or too small to show up on our calculators. Okay. So this means that my decimal got moved back 10 times. So if I moved it forward 10 times, come on, 4, 1, 8. That's 3 times. 4, 5, 6, 7, 8, 9, 10. That's the number. There you go. Yes. So, again, showing it to you because it could happen again in the future when your numbers get real big. It shows up times 10 to the 10th. I think the TI-84s, it had an E. It had the 4.184 something something, and then it had E to the 10th at the end. That's the same thing. It's showing the same thing. Okay? Any questions for me right now before you start working on anything? You need any clarifications? Okay. All right. Well, then for the rest of class, please work on your worksheets. Again, make sure I have 10-4 from Tuesday, and then work on 10-5. If you get it done, give it to me. If you don't get it done today, give it to me tomorrow.